here is one of the activities I do with my students that relates to STEM, and we're going to talk about mechanical advantage and gear ratios, and I like to bring in one of my old mountain bikes and use it as an example and compare it to the old days of the high wheeler and how they did not have gears to change mechanical advantage in those days. In a situation like this, we can talk about how these gears on the bicycle can help us achieve different things like the speed, the desired torque, direction, rotation, the distance of travel, efficiency, synchronization, things like that. And in that situation, we look at, say, someone riding at a pedaling cadence of 60 revolutions per minute with a gear ratio of 42 in the front and 16 in the back, and with a 26-inch wheel. And so the students come in and they calculate things like, well, if the diameter of the wheel is this, and we can multiply that by pi and get the circumference, then we can take it to the board and we can say, with a driven gear of 16, a drive of 42, we have a 38-to-1 ratio. And in that 38 to 1.38 to 1 ratio, if we are at 60 RPM or a cadence of 60, we're traveling about 158 turns of the back wheel every minute. You multiply that by the circumference of that wheel, which this one happens to be about 82 inches, and quickly you find out that you're going almost 13,000 inches every minute. We can take that, do the rest of our math, as you see here, kind of see it in our illustration here, and you find out that we're traveling about 12.21 miles per hour in this situation. In this, we can talk about the difference between radiuses and diameters and circumference and area and things of that sort. We can also talk about things like mechanical properties, things like weight and